Let's go ahead and take a look at a few more challenging problems, a little bit more complex, that involve expected value. So again, you're going to want to pause and look at, get down these values, or go ahead and look at the notes that I've posted, and you can get these values down too. But you will see in each of these, what's important is that we need to create the distribution. We got to look at the probability distribution. We got to get the right values. What is the variable? And then what is the probability for that outcome, right? And so these lottery tickets, right, are a game of chance, and the random variable in this case is how much money you win, right? And there's a probability associated with that. Yeah, you can go ahead and read this, but you could see for a $5 ticket, right? Sorry, you're going to pay a $2 ticket, right? You win $5, but really what you win, right? Even though you win $5, you only win $3 because they don't give you your $2 back. So it's your winnings minus what you paid per ticket. So notice your X values are $2 less than what you win. Now these probabilities were calculated by the chances of winning, as it says, 1 in 1,000, 1 in 1,000,000, right? And so you have these values here. And then this one's important in that you lose $2, -2, 98.899%, right? And you get that from doing 1 minus. So once I know the probabilities of what I'm going to win, right, you add that up and then you do 1 minus that to get you the probability that you're going to lose. And so that's where this value comes from, 1 minus this number here. And so once you have this distribution, then you just have your expected values, x times p of x, x times p of x. I think that's easier to do for expected value. Now, on my online homework, inside there, I show you how to calculate the expected value. So you'll find that inside the using what we call the ARDA-STAT to do that. So look on the online homework to do that, but I think it's much easier just to do a simple calculation. A lot of entering, and it's not as easy on the ARDA-STAT because it's just x times p of x. You have two more kind of complex, more complicated situations that take a little bit more thinking, or my support really is you have, you're playing a game, you either win or lose 2, and now I have to calculate the probability of winning and losing, and so I have to use some of the module 4, right? So in this game of 52 decks, 52 card deck, you pick 2 cards. If you get 2 red cards, you win. So what's the probability of winning $5? You got to get 2 red cards, and so that's 26 red cards out of 52. And once you've picked the first one is red, the chance the second one's red is 25 out of 51. Remember, this is without replacement. I'm not replacing, and so it alters the probability a little bit. And so that's why you have 25 out of 51. And then that you lose $2, it's going to be 1 minus the probability that you win. And so I don't have to do any calculations. I just do the 1 minus the complement rule. And then once you have your distribution, you calculate your expected value by multiplying x times p of x. And then you now know if you play this game, this is what's important in the gaming industry. You can see these outcomes. You can see in this lottery that you expect to lose, right? $1.41 in this one. So if you played 100 times, you'd expect to lose $141. Even though you'd win sometimes, you would still lose. So you'd play 100 times, that's $200. You would lose 141. On average, right? Some people may win the full jackpot, and that doesn't apply to them. But on average, that's the average what people lose. And then this game here, this kind of made-up game, you lose 28 cents, about 28 cents or 28.5 cents per game. So this is a losing game if you play it. It's a losing game. Continuing on, let's see. This one, again, is a popular question about risk and assessment and insurances. All insurances are gambling, right? And they're gambling that you're not going to get in an accident, you're not going to die. And then you pay them a premium for that. And so that's why insurances are high for cars or for people who are higher risk. The probability of an accident is increasing. They charge you more. And so they've done these calculations here. And so important in this one, this life risk one, is first you have a 0.341% chance, and notice it's 0.0034 because you have to move the decimal twice or divide this by 100. And then notice if you die, right, this percent, you get 125,000 or the insurance company would lose 125,000. But notice it's 124,550 because you paid 450. They don't pay that. They don't give that back to you. So it's similar to what we had to do in the lottery problem. Subtract out that originally cost, because again, what's the value of this policy to the insurance company? And then 99.659% of the time, right, they make 450 on you. And then what's the expected value? Right, you can look at some of these calculations, what we've done here. So they make $23 on average per policy. So if they sold 100 policies, they would make $2,300. Just imagine if they sold 100,000 policies, add 2 zeros to that, right? And you got $23,230,000 per policy. So sometimes they lose, but overall they're going to win. They end up going ahead, and that's how insurance companies make their money with that. So again, there are more examples in the homework to look at, and then in there you have how to do using technology you could find in the homework.